We're at the General Motors Proving Grounds today to discuss vehicle handling. With help from experts from Tire and Wheel and Vehicle Handling, we'll get front row seats to all the action to see vehicle handling problems as the tire meets the road. Hello, I'm Ken Moriarty. After we see what handling problems really are, we'll know their symptoms. Knowing handling symptoms is the basis of a better way to diagnose and correct vehicle handling complaints. Many customer complaints fall into the category of poor handling. This is a very broad area that literally encompasses the entire vehicle. However, diagnosing handling complaints is not really difficult. In fact, if the customer accurately describes the symptom to the service advisor, technicians can immediately start to work in the right direction. Vehicle handling symptoms include pulls, torque steer, steering wheel oscillation, poor on-center feel, and poor returnability. A pull is a condition where the vehicle tends to steer either right or left from straight-ahead travel. Pulls require noticeable effort on the part of the driver to keep the car going straight. Torque steer occurs only on front-wheel drive vehicles. Upon hard acceleration from rest, the result is a very strong left or right pull. An opposing pull may be evident upon deceleration. Torque steer diminishes at cruising speeds and should not occur at all when the transaxle is in neutral. Steering wheel oscillation is a front-wheel drive handling symptom in which the steering wheel moves on its own, slightly right, then left, at a constant or random rate. Oscillation can occur while the vehicle is under load, while on a straight and level road, or while climbing a slight grade. The actual direction of the vehicle is not affected. Poor on-center feel, known as wander, describes a symptom in which the customer cannot easily find the steering wheel's center position. Constant steering corrections are needed to keep the vehicle traveling straight. Poor returnability occurs when the steering wheel does not center itself after a turn. The driver must turn the steering wheel back to center. Pulls can be caused by tire-related factors, incorrect trim height, improper wheel alignment, or dragging brakes. Pulls are caused by unequal left-to-right suspension forces. If one tire is properly inflated and the other is underinflated, the tire with less pressure has a decreased diameter and an increased rolling resistance. This causes the vehicle to pull toward the side with the low-pressure tire. Excessive or incorrect alignment and incorrect vehicle loading also contribute to steering pulls. Torque steer is caused by unequal drive axle angles that create an additional force or steer torque at one front wheel. Steering wheel oscillation is caused by steer torque, brought on by the car body slowly raising and lowering on the suspension on smooth roads. Changes in body height alter CV joint angles. Poor on-center feel can be caused by loose, binding, or damaged components, incorrect tire pressure, or insufficient caster. Poor returnability is caused by binding components or incorrect caster. Many handling complaints are directly related to wheel alignment angles, namely camber, caster, and toe. In addition to the three angles, several non-adjustable angles are equally responsible for handling characteristics, such as straight line stability, steering wheel returnability, and tire life. Worn components such as control arm bushings, tie rods or tie rod ends, Idler arms, strut assemblies, and stabilizer bar bushings can affect vehicle handling. Worn components may allow movement under load and prevent an accurate wheel alignment because the settings change the moment the vehicle moves. Remember, checking unloaded components may show movement that is considered normal. So, with the weight of the vehicle on the suspension, check for loose or worn suspension components. Worn components can cause noise, misalignment, or uneven tire wear. To illustrate proper repair techniques, first we'll look at the adjustable angles: camber, caster, and toe. Many front-wheel drive vehicles also have provisions for rear-wheel toe and camber adjustments. Camber is the amount of inward or outward tilt of the tires. Camber affects directional control and tire wear. Camber is measured from vertical. A vertical tire has zero camber. An inward-leaning tire has negative camber. An outward-leaning tire has positive camber. When a properly aligned wheel encounters a bump, the suspension compresses as the control arm swings up, so camber moves more negative. When the wheel encounters a dip, the suspension extends as the control arm swings down, so camber becomes more positive. These camber changes help improve vehicle handling. Camber changes when the suspension system moves. The proper camber assures maximum tread wear and handling. When camber is equal on both sides, the vehicle drives straight down the road. When camber is not equal, the vehicle pulls toward the wheel with the most positive camber. Another type of pull is caused by road crown. Road crown pull is road-induced. The amount of side force causing the pull depends upon the degree of road crown. Road crown pull can be corrected on front-wheel drive vehicles by adding half a degree of positive camber to the left front wheel. This correction, however, can cause left pulls on flatter roads. Rear-wheel drive vehicles use caster to compensate for a road crown pull. Viewed from the side, caster is the angle of the steering axis from vertical. Positive caster tilts the top of the steering axis rearward. Negative caster tilts the top of the steering axis forward. The wheels steer around this line. Viewed from above, caster determines how the steering axis handles tire side forces in comparison to the tire contact patch in a turn. When positive caster projects the steering axis ahead of the contact patch, the tire side forces tend to push the tire back behind the steering axis point. This increases steering stability and returnability. When negative caster projects the steering axis behind the contact patch, the tire side forces tend to push the tire away from center, reducing steering stability and returnability. As a rule, the vehicle pulls toward the side with the least positive caster. On the other hand, front-wheel drive vehicles can have caster variations without noticeable effects. Once a vehicle's alignment is set to specification, pulls should be reduced. However, road crown, tire, and drivetrain effects can require more camber or caster to compensate for straight-ahead travel. Pulls are toward the most positive camber or the least positive caster. Toe is the third adjustable alignment angle. Toe is the most important tire wear angle. Proper front toe settings promote tire life and assure steering wheel angle. Toe measures how much a wheel points toward or away from the vehicle's center line. When the wheels are parallel, toe is zero and tire wear is reduced. When the wheels point in, toe is positive. This is called toe in. When the wheels point out, toe is negative, called toe out. Toe changes very little for front or rear wheel drive vehicles. Most toe specifications are very close to zero. Other than tire wear, the most noticeable effect of an incorrect toe setting is a misaligned steering wheel. If the only customer complaint is a misaligned steering wheel and not a pull, a toe adjustment is the only required action. Proper rear-wheel toe adjustments control tire wear and thrust angle on those front-wheel drive vehicles with adjustable toe on the rear wheels. While the front wheels steer the vehicle, The rear wheels control the thrust angle. The thrust angle is the path that the rear wheels take. As long as the thrust angle and vehicle center line are the same, the rear tires, front tires, and the vehicle travels straight down the road. However, when rear toe is out of adjustment, the thrust angle changes and the vehicle dog tracks, following the thrust angle, not the center line. A rear toe adjustment is used to set the thrust angle. That covers the adjustable angles. Now, let's look at some non-adjustable angles, such as turning angle, steering axis inclination or SAI, and setback. Turning angle, sometimes called toe out on turns or Ackermann error, refers to the differences between the left and the right steering angles in a turn. This toe change is necessary because while turning, the outside wheel travels on a different radius than the inside wheel, requiring a larger turning angle for the inside wheel. If the turning angle is incorrect, the usual symptom is tire squeal at parking lot speeds, as each tire turns on the wrong angle. The tire squeals, trying to make up the difference between its actual turning angle and the correct turning angle. To check turning angle, begin by correctly adjusting toe. Next, with the wheel set straight ahead on protractor turn plates, turn the left wheel to the left until the protractor reads 20 degrees. Then, check the setting at the right wheel. It should be less than 20 degrees. Then turn the right wheel to the right until the protractor reads 20 degrees. Check the angle of the left wheel. It, too, should be less than 20 degrees. When both turning angles readings are compared, the difference should be 1.5 degrees or less. Excessive readings indicate a bent steering knuckle. Another non-adjustable angle is steering axis inclination, or SAI. SAI is also called kingpin axis inclination, known as KPI. When viewed from the front, steering axis inclination refers to the inward tilt of the top of the steering axis. The steering axis touches the road within the tire contact patch. SAI changes spindle height as the vehicle is steered. When the spindle is high, the wheel is straight ahead. When the wheel turns, the spindle moves down, lifting one side of the vehicle body. The weight of the vehicle acting on the spindle tends to push the wheels back to the straight-ahead position. The next non-adjustable angle is the included angle, a combination of camber and SAI. To determine the included angle, either add positive camber or subtract negative camber from the SAI. The included angles on each side of the vehicle should normally be within 1/2 degree of one another. If the included angle is incorrect, the front strut, knuckle, or spindle assembly is bent. Bent knuckles affect included angle, camber, and toe. When camber is incorrect, the vehicle can wander and pull. Bent knuckles indicate strut or ball joint damage that affect returnability. If damage is not evident and camber can be set, there is no need to correct included angle. Otherwise, replace the damaged component and align the vehicle. Another non-adjustable angle that affects handling is setback, a side-to-side wheelbase difference. Bent suspension components, a misaligned body or frame, or a collision can produce setback. Now that all of the alignment angles have been covered, let's move on to symptoms, causes, and corrections for torque steer, steering wheel oscillation, and poor on-center feel. Recall that torque steer occurs on heavy throttle application as a noticeable change in steering wheel pull and vehicle direction. Both outer CV joint angles are equal when the drivetrain is level. The front wheels receive an equal amount of drive torque and an equal amount of toe-in type steer torque. Upon heavy throttle from rest, the engine moves on its mounts. The result is unequal outer CV joint angles. More left steer torque is developed, causing a stronger toe-in force at the left wheel. As left steer torque overcomes right steer torque, the vehicle torque steers to the right. Body lift causes greater CV joint, camber, and toe angle changes. The toe angle changes are due to an improperly mounted steering rack. To test for torque steer, drive the vehicle. Using safe driving practices, apply heavy throttle from about 10 miles per hour. If the vehicle has a torque steer problem, an obvious pull occurs immediately. Slight differences in tire circumferences influence torque steer. When tests indicate a torque steer, cross-switch the front tires and road test the vehicle again. If torque steer occurs in the opposite direction, the probable cause is the front tires. Bring the rear tires forward, one at a time, to find the combination that produces the least amount of torque steer. If the vehicle still torque steers, the tires are okay, and the cause is improper engine transaxle positioning. Engine mounting plays a crucial role in handling engine movement. Loose, worn, damaged, or mispositioned engine mounts are major contributors to CV joint angle changes. The Park Avenue and LeSabre torque axis mount is factory assembled with a 6 mm shim between the mount and frame rail. For left torque steer, remove the shim. For right torque steer, add a 3 mm shim. A total of 9 mm of shimming is allowed under this mount. Remember, when adding shims, use longer bolts. If the shimming procedure does not fully cure the torque steer problem, install an angled torque strut and bracket. An angled torque strut is mounted on a 40-degree angle. The angled torque strut immediately stops engine movement. Torque steer is reduced whenever CV joint angles are controlled. The next symptom is slow steering wheel oscillation on Park Avenue or LeSabre, noticeable at cruising speeds on smooth roads. Even smooth roads cause some suspension movement, which changes the trim height. As trim height changes, CV joint angles, toe, camber, and tire loads continuously change. In fact, camber angles change about 1/4 of a degree for every inch of trim height change. The changes in unequal CV joint angles result in slight torque steer effects, similar to accelerating and decelerating. This is enough to pull the steering rack gear back and forth. Another possible cause of oscillation is a dynamic imbalance of the front wheel and tire assemblies. In either case, as the rack moves, the pinion gear rotates the steering column shaft and steering wheel. A service kit has been released to solve steering wheel oscillation caused by the torque steer phenomenon. A steering column damper is fitted to the lower end of the steering column. The damper may also reduce mild pull conditions. A garter spring applies a clamping force to add friction to the steering shaft. The extra friction eliminates steering wheel oscillation. Now, let's talk about improving poor on-center feel. Begin with a tire pressure and a toe angle check. Then, check the steering system for excessive lash, worn ball joints, worn tie rod ends, loose gear mounts, or a worn intermediate shaft. Then, look closely at the caster angle. Too little caster and or high tire pressures reduces the wheel's tendency to track straight, causing a poor on-center feel. If caster is out of specification, then vehicle or component damage exists. Correct any damage before attempting further diagnosis. If caster is within specifications and the symptom persists, on a Park Avenue or LeSabre, add a small amount of additional resistance to the steering system to eliminate the poor on-center feel. The repair is the installation of a stiffer rack adjuster spring. With more tension, the replacement part should improve the poor on-center feel. The next time a vehicle test drive shows that a real handling problem exists, its reason may be quite simple. That is, if everything that makes a vehicle handle properly is looked at carefully. Bent, damaged, or misaligned steering, suspension, or engine mount components can't be readily seen, so rely on what those simple measurements and the alignment rack say. That's the best way to repair the customer's vehicle.